All right, so we can only hope that this course isn't a major source of stress for any of you. Sometimes it's a source of stress for us. Right? But we hear a lot of messaging about stress and health and the potential interactions between stress and infectious disease. And a lot of people have been asking questions about this. This has particularly come up in a lot of the understanding about herpes viruses, where people tend to see flare-ups of herpes viruses when they're under acute stress because of things in their life and what have you, right? So I want to open up the broader question of how does stress impact both susceptibility, so you're likely to becoming infected, and the expression of disease symptoms, so how severe the infection with a pathogen can be.
So do you want to start with herpes viruses?
I want to start with herpes viruses.
Yes, so to start with herpes viruses, herpes simplex virus is certainly a classic one where we know that symptomatic lesions are frequently induced after an extremely stressful experience. So to give examples, that would be something like a long bout of drinking, as students might do, or preparing for an exam. Even sitting in a hot tub, which feels relaxing, is actually a physical bodily stress. So it doesn't have to be something unpleasant, but something that really changes your body chemistry or your body environment and your physiology. For a herpes virus, that is the type of thing that can wake it up out of this quiescent or latent state. And it's not that your body in particular releases a molecule that would directly bind to the viral genome or a protein there, but more that there's a signaling cascade of steps in between your body's response to a stressor and the immune system, which is normally providing surveillance on the one hand, and also the neurons that this virus in particular goes latent in. And so for the viruses that I study, you think about both of those, but I think for many of the other pathogens that we can comment on, we're really mostly talking about suppression of the immune response or transient depression of the immune response that allows a flare-up to take place or an infection to get through a barrier that should have otherwise stopped it.
Can I ask you another herpes-related question? Yeah. So one thing which I found really puzzling is, so with the simplex virus, it seems very clear that the quiescence and reactivation is a great strategy and they come out of dormancy, I don't know, every few months or every half a year or whatever. I don't know quite how often it happens, but it's clear that it's very good for transmission, maintaining the chain of transmission. And now I've been always wondering about chickenpox since chickenpox is acute and transmits very well, but then the quiescent phase can last for decades.
It does.
And so do you think so my question is, so to what extent do you think is shingles an important epidemic? So it's clearly medically very important because it's painful and horrible, but epidemiologically, how important do you think shingles is for that virus?
The folks who spend their whole lives and their lives studying VZV think that the theory for why this happens is that it's actually grandparent to grandchild transmission, and that's the cycle. Isn't that neat? When this was first suggested, I thought, oh, that's what a neat and different strategy, right? It's unfortunate that this is the case medically speaking, but from the virus's perspective, shingles and the reactivation that happens in that upper level generation provides a great opportunity to get past the immunity that most adults of our age have and reach the non-immune children of, who are in essence the grandchildren.
So there's infectiousness going along with shingles?
Yes, oh yes.
Skin?
Mm-hmm. So the painful, difficult nature of shingles is the part that lingers on afterwards. It's often called neuropathic pain. But that initial moment where you have this dermatome that comes out with a visible lesion, people are extremely infectious. And it doesn't always happen in people of the grandparents' age. I've known plenty of people my own age who can have shingles and outbreaks, but they'll literally advise you to stay away from your own young children or from other people's young children during that stage so you don't infect them. And once it's in young children, they also transmit horizontally.
So in evolution terms, grandparents are a bit of a conundrum. So most organisms die after reproducing, and you don't have this long period of time after, say, menopause in women where you have a very active life. And in terms of evolution biology, we've come around to understanding, with a lot of data from long-term studies of Finnish populations over many hundreds of years, that grandmothers perform a very essential duty. It's called the grandmother effect. They help their daughters raise their granddaughters, and because of kin selection, this is beneficial. And you can see that the benefit of a grandmother when the mother is having male offspring versus twin male offspring versus female offspring, because males are more expensive, the grandmothers allow those offspring to grow up. So my question is, do we know if shingles is more present in females, grandmothers, versus grandfathers?
You know, I don't know the answer to that question. I'll have to look it up afterwards. I can certainly say that it's an unusual strategy. I agree with you. The grandparent strategy for that as a virus to reactivate there and move on. But something that's useful to reflect on for herpes viruses is that they're very species specific. So this human one didn't cross over into humans anytime recently. It's been millennia. So as long as it took to evolve the grandmother effect, that's how long varicella zoster virus had to evolve this parasitism of grandmothers to grandchildren. But
So does that suggest that this is
it's-
this is a strategy that we don't see in other mammals, or are there other examples outside of human systems where this kind of multi-generational transmission effect happens?
There wouldn't be any reason to believe that this wouldn't be happening in the primate alpha herpes viruses, for instance, or the ones that happen in bovines, but I'm not sure if anyone's looked to find that age of...
But the very long latent period, that seemed to be quite unusual for shingles, isn't it? Because the decades thing, if you were a virus of a rat or something, then being quiescent for a decade wouldn't give you much bang for the buck.
Yes, I agree. There might be corollary examples in the animal kingdom, but it may be that the humans are the most exaggerated because our lifespan is among the longest.